Today we're going to set up a nonlinear plastic analysis of a bracket. We'll begin by creating our simulation files, and we'll select the multi-step nonlinear solver. Next we'll select some output requests. You could set these as your defaults if you want, but we want to make sure that we're getting contact results so we can see the contact pressure and our plastic strain. Alright, and also because we're going to be running material nonlinearity, we'll turn that on as well as our large strain. And finally we'll create a nonlinear static subcase where we'll specify an end time and number of increments that we'd like to run for our simulation. Now we can prepare our geometry for meshing. I'm going to be using layers to manage visibility, so we'll put our solid bodies on layer 11. I'll go ahead and get an associative copy of the bracket first by wave linking it. Now before we mid-surface, I also want to create a ram that will be coming down and plastically deforming the bracket here. So we'll do that by creating a sketch to create our ram. Here I'll just specify the location and a vector, and I'll specify one normal to that surface at that point. And I'm just going to be creating a rectangular ram here, and we'll extrude it 2/10 of an inch up. So you can see it's just barely in contact with the bracket there. Alright, so that's quite a bit thicker than our bracket, and that's as designed. We'd like it to not deform as much as the bracket. Alright, next we'll assign a material to the solid body. Now I already have a material specified for the bracket. It's a nonlinear material as well, and we'll take a look at that in just a moment. But first we'll make our work layer 12, and we'll create our mid-surfaces so they'll be on layer 12. Alright, so that looks good. So now we'll go to the FEM where we can create our mesh. We'll put our mesh on layer 12, which is where our mid-surface is. So I'll make that our work layer. And then we'll go ahead and create a C-quad 4 mesh with a global element size of 0.4. And I had temp free map meshing on, so you can see we get a nice map mesh on our bracket and our ram. Now, because we had assigned material to the CAD model, we can inherit that into the simulation model to reduce a potential source of error. And here we can check what material was applied from the CAD model by selecting information on the mesh, and here we can see not only the number of nodes and elements, but also the inherited material. So there we can see our 310 on our ram, and if we go down to the other mesh, we can see that steel rolled. And that's our nonlinear material that we had assigned to our bracket. And if we'd like, we can take a look at that material. Let's go ahead and inspect it. And what we'd like to look at is the stress-strain curve that's assigned to that material. So here we can plot it. And there we can see our stress-strain curve. If we'd like to take a closer look at the linear portion of it, we can zoom in on that. And there you can see the linear portion of the stress-strain curve. All right, so not only can we inherit material, but we can also inherit the thickness from the mid-surface. Here I've plotted that thickness as a contour plot, and here you can see we're inheriting from the mid-surface at the element centroid, which eliminates another potential source of error. All right, so that looks good. Let's go to our sim. Let's go ahead and turn off all the layers except for 12, which has our mesh and our geometry on it. We'll make that our work layer and turn off everything else. Then we can go ahead and put a fixed constraint on the ends of the bracket. Here I'll select polygon edge, and I can box select the ends. There's 5 edges on each end for a total of 10 objects. And then we'll put an enforced displacement constraint on the vertices of our RAM. So here I'll go ahead and select those 4 vertex points, and we're going to constrain it in all degrees of freedom except for DOF2, which is Y. And we'll put in a time-based field that will control our enforced displacement of those vertices. So at time 0, we'll have it at its original position 0. We want it to move down 0.8 inches. So I'll put minus 0.8 at 1 second, and then we'll have it come back up and be at its original position at 2 seconds, which was the total time we had specified for our analysis in our subcase. And lastly, we'll specify our surface-to-surface contact. And here I'll do that manually. You can automatically have it detect contact pairs based on a separation distance that it can search for pairs. But here we'll do it manually. We'll select our top surface RAM as our source, and then a couple of faces on our bracket as our target region. Here we can put in a coefficient of static friction, as well as min and max search distances in case there's any initial penetration or gap. Lastly, we can take a look at the multi-step nonlinear kinematic contact parameters, and these are all the defaults. I'm not going to save any of these, but just wanted to show you that there is an offset automatically put in for half the shell thickness. Alright, so let's go ahead and run it, and we'll leave the video running during the solve. Normally I pause it, but here let's go ahead and take a look at the solution monitor, because there's some nice features here in the monitor that allow us to view the progress of the solution as it's solving. So here we can view the displacement magnitude. We can see that RAM coming down, contacting the bracket, and the bracket deforming. All right, we can also take a look at convergence plots. And it looks like it's done. And the preview looks good. So let's go ahead and take a look at our results. And here you can see we have 20 increments for our nonlinear results, and we'd like to look at the contact pressure, and we'd like to look at a top and bottom view. So here, as I drag that in, I can select the top and bottom, and it puts the contact pressure in the bottom. Then we'd like to put our plastic strain results. Here I want those effective plastic strain results up in the top. Then I can synchronize the views, double click mouse button 1 in order to fit the view there, and then I can select both views and animate. And we want to animate across iterations, so that way we can see all of the iterations. As the RAM comes down, plastically deforms the bracket. There you can see the plastic strain on the top as well as the contact pressure on the bottom.